Welcome you all. Myself, Professor Girish Navale. I'm working as assistant professor in computer engineering department, and today I'm here to introduce you the basic concept of Arden's theorem. So, what is Arden's theorem? Let's see. So, basically, in Arden's theorem, uh, there are two equations. One is R is equal to Q plus RP, and other one is R is equal to QP star. So, we need to remember these two equations: R is equal to Q plus RP, and R is equal to QP star. So we'll see how to solve the different states by using Arden's theorem. So you can see here the diagram is given. Here there is a Q0 state, Q1 state, Q2 state, and Q3 state. And 0 and 1 are the inputs for the different states. Okay. So here you can see Q0 is a start as well as it is a final state. And others are Q1, Q2, and Q3 are the intermediate states. So here Q0 is a start as well as final state. So let's see how to solve this by using Arden's theorem. So we know that Arden's theorem has two equations: R is equal to Q plus RP, and other one is R is equal to QP star. So here we have to form the different equations for the different states. Okay, now how to form the equations we'll see one by one. So Q0 is a start state. So Q0 is a start state. So let's see how to form the equation for Q0. Now we'll check the incoming arrows for Q0. So how many incoming arrows are there? So this one start is empty. Empty input is coming, but it is not coming from any state. So I'm writing Q0 is equal to epsilon. Now again, there is one input is coming to Q0, that is from Q1 to 1. So I'm mentioning that Q0 is equal to epsilon plus Q from Q1, one input is coming. So Q1 dot 1. And again, from Q2, again, there is one input is coming to Q0. Uh, that is Q from Q2, it is for the input 0, it is coming to Q0. So my equation for Q0, it will become Q0 is equal to epsilon plus Q1 dot 1 plus Q dot 0. So this will be my equation number 1. Okay, so equation 1, so this is for Q0. Now we'll solve for Q1. So how many incoming arrows are there? Oh, okay, there is only one incoming arrows, that is from Q0. So I can say for Q1 there is a Q0 to 0. So Q1 is equal to Q0 to 0. So this is equation for Q1. Now let's see how to find out the equation for Q2. How many incoming arrows are there? There is only one incoming arrow is there from the state Q0. There is only one incoming arrow. So I will mention Q0 dot 1 is equal to Q2. Now we got three equations. One is for Q0, Q1, and Q2. Q0 is equal to this one, Q1 is equal to this one, Q2 is equal to this one. So why we are not forming any equation for Q3? That is question. Because in Arden's theorem, basically we are solving the equation for only final state. So what is final state? Q0 is equal to epsilon plus Q1 dot 1 plus Q2 dot 0. But here, as Q0 is a final state, there is only requirement of Q1 and Q2. There is no requirement of Q3 as such. Okay, so no need to form any equations for Q3. That's why we have not formed any equation for Q3. We have derived equations only for Q1 and Q2. Now Q0 is equal to epsilon plus Q1 dot 1 plus Q2 dot 0. This equation we need to solve further. So okay, so we are taking the equation as it is. So we are giving Q0 is equal to epsilon plus Q1. Can we substitute any value of Q1 here? Yes, that is from Q0 to 0. So we are putting that Q0 to 0 as it is in equation Q1. So Q0 to 0 dot 0 in equation as in Q1 dot 1. So we again for Q2 we are substituting the value of Q2, that is Q0 dot 1 here in equation Q0 dot 1 dot 0 as it is. Now can we take anything common here? So Q0 is equal to epsilon plus, you can take common Q0. So we are taking common Q0 plus what we are getting as a common 0 1 plus 1 0. So what is the equation we are forming here? Q0 is equal to epsilon plus Q0 dot 0 1 plus 1 0. Again, so this equation we form for q0. This is our final state. Now can we compare this equation with r is equal to q plus rp? Yes, we are comparing this equation q0 is equal to epsilon plus q0 dot 01 plus 10 with r is equal to q plus rp. So what we are getting, so we are getting as q is equal to epsilon, r is equal to q0. We are getting p is equal to 01 plus 10, and we are getting all the values of r is equal to q0. Okay, so what is the equation for final Arden's theorem? That is r is equal to qp star. So by comparing this equation with r is equal to q plus rp, we derived the different values of q, r, p. Now what is the last remaining? R is equal to qp star. That is our equation. So again, r is equal to qp star. What is the value of q? Q is epsilon. What is the value of p? The value of p is what we are getting is 01 bracket 0 bracket in bracket 01 plus 10. So we are forming the equation of q is equal to epsilon bracket p in for p 01 plus 10 bracket star. So there is nothing for epsilon, so we can say r is equal to in bracket 01 plus 10 star. So this is our, we can say it's a final equation for the Arden's theorem. So only two equations are important: r is equal to q plus rp, r is equal to qp star. Then you need to form the equations for the different states. Then you have to compare this equations with r is equal to q plus rp, and again you have to form the equation. So this is our final answer: r is equal to 0 1 1 plus 0 bracket star. So this is all about Arden's theorem.